Hello, everyone. We're just going to be waiting a couple of minutes for people to join, and then we'll get started with some of the Comet updates for the last couple of months. Lots of exciting things to show you today, focused on large language models, but also computer vision and just more general workflow related improvements. So looking forward to kind of digging into those with everyone. So we'll just wait 1 or 2 minutes for people to join in. I can see that it's already filling up nicely. So we'll wait 30 more seconds and then we'll be able to jump in. Awesome. I think we have a good group. People might be able to join midway through, but I think we can get started. So yeah, thanks very much for joining, everyone. As I mentioned, we'll be covering a lot of product improvements that we've made over the last couple of months. That means if you do have any questions about the Comet product or any of the features that we're going to be talking about today, feel free to pop in your question in the chat, and then either Daniel and I will be covering them as we go. So I'm Jacques, head of product here at Comet, and we have Daniel, senior product manager in charge of experiment management, and to walk you through some of the features that we've released. So one of the first things we'll kind of talk about quickly is just the Comet platform, all of the different moving pieces and what we'll be focusing on today. The Comet platform includes a number of features that span the entire machine learning lifecycle, all the way from data preparation and data management, all the way to production monitoring. What we'll be focusing on today is some improvements we've been making on the experiment tracking side of things and on the model registry as well. So I'll be covering some LLM improvements we've been working on, and then Daniel will cover some additional visualizations we've added on the computer vision side of things. So to jump, to jump in first on LLMs. As everyone knows, LLMs have kind of taken the world by storm over the last few months. And one of the things that we've done on the Comet side is really talked a lot with our users and our customers and really focused on some of the challenges that people have been facing in large language models, especially when it comes to all of the workflows related to building machine learning applications that rely on these large language models. The first thing that we noticed was that the introduction of these large language models have led to completely new workflows that data scientists are now using to be able to build models and applications. And so while in the past, people would have mostly been fine-tuning large language models or even training these models from scratch, usually using Hugging Face, for example, people are now doing a lot more prompt engineering, especially since OpenAI have released their APIs for GPT-3, 3.5, and now even 4. And so that has had a pretty big impact in terms of how people are working. When you're fine-tuning a model, you have your training data, you train your model, you do a lot of model training, hyperparameter tuning, and just refining your data set or your model architecture until you get the right model. You're evaluating loss curves over time and other performance metrics, and then you finally deploy your model. That workflow is still relevant for large language models when you're fine-tuning. And this is a workflow that Comet has supported very well in the past and continues to support very well. And so you're able to visualize all of that information within the Comet platform, and you're able to compare, you're able to share those results with everyone, with your team members, and reproduce all of your different experiments. When we look at the prompt engineering workflow, that workflow is actually very different. in a prompt engineering workflow, you're actually reviewing prompts and responses on a small scale much more often. So you'll be writing your prompt template, evaluating it on 10 or 20 or maybe even 100 samples, and then you would be kind of reviewing the performance on those 100 samples, and then you'll be updating your prompt template. And so instead of looking at loss curves and accuracy metrics over time, since model training takes a long time, instead it's much more rapid iteration focused on reviewing data. And so that's the workflow we've been hearing from a lot of different prompt engineers and data scientists working with these large language models. And so for that reason, we're happy to kind of announce a new type of Comet project. We continue to have experiment management projects, which are focused on loss metrics, accuracy curves, and a lot of the kind of more traditional use cases and visualizations around training, deep learning models, and classical machine learning models. But large language models are really projects and views that are tailored to the prompt engineering workflow. In these projects, you will be able to analyze your prompts, analyze responses, able to log metadata, to group your information, but also to search all of these different prompts. Some of these features are already available on the Comet platform, and I'll show you how to use them today. And some of these are going to be released very soon, over the next week or so. And we also have a number of other improvements coming down the line. And so search capabilities within all of the prompts and responses that you're logging will be available by the end of next week. And then we also have chain visualization and support, as well as support for embeddings, which will be coming before the end of the quarter. So really, what we're really focusing on is how are the workflows for prompt engineering different from fine-tuning workflows, and how can we build the best analysis tools for these? For these kind of new LLM projects, we've created a new Python SDK available under Comet-ML/Comet-LLM. This new SDK is open source. So if you have any feedback, any improvements, feel free to raise an issue there. We're really looking forward to getting feedback from the whole community on this. And logging a prompt, it becomes super simple. All you need to do is import Comet_LLM, and then just call comet_LLM.logPrompt. You can pass in your API key, your prompt, your output, the duration, and any associated metadata. So you can pass in the model name, but also things like your usage tokens. All of this information will then become available within the Comet LLM Projects UI. So let's take a quick look at what that looks like today. So the first thing that you will notice when you go to the Comet platform is you can now go into new project. Let me make sure I have everything configured correctly. So you can click here, new project, and you will see that we have a new project type. So you have the experiment tracking project type, but you also have now the large language model project type. And so this is how you're able to create a new project with these tailored views for large language models. Just waiting for my VPN to connect. Awesome. So here you can see that we already have a large language model project demo. We can see it's an LLM project. And what you're able to see here are all of the different prompts and responses that I've logged, as well as any additional information. So what I'll do here is I'm actually going to customize my columns. I don't use the project template, so I'm going to remove that. And I'm just going to add some of my usage information for all of my different prompts. And you can see here that we can see the duration, total usage for all of these. You'll also notice that I've been grouping all of my prompts per model. And one of the things that we'll be looking at, and so you kind of have a lot of the functionality available within experiment management, available within these large language models as well. One of the particularities with large language models is your prompt and your response can be very, very long, this is why we've implemented a new sidebar option here, which allows you to view your response, your input prompt, as well as all of your metadata in a much more flexible way. And so if your response starts being 2 or 3 or 4 paragraphs long, then all of that information will be easy to read and review within this sidebar here. And so you can see here, I can go very easily navigate and review all of my different prompts very quickly here from the Comet UI. In addition, one of the things that we'll be releasing kind of next week, so if you start using LLM projects today, you won't quite be able to see this search bar, but you will next week, is adding the ability to actually filter and find specific prompts that match your use cases. So let me just quickly remove the group by. We'll make it a little bit easier for us to view everything. There we go. Let me close this here. And so here you can see that I have all my prompts. I have 251. What I can do is I can actually search for all of the prompts that contain the word numbers, for example. When I search, you'll see here, maybe number. You'll be able to see here all of the different prompts that match with this search query. So let me just tailor it. So let's see. Oops, if we can search for this one. I'm not entirely sure what's happening. So this search functionality here will allow you to filter all of your different prompts and really start finding the ones that you're looking for, analyze them in more detail in conjunction with the columns and the group by functionality. So this is the functionality that we have today within large language model projects. As you can imagine, it's a very fast evolving field. And so we will be adding support for chains, adding support for visualizing embeddings of your prompts and your responses over the coming weeks. If you're interested in kind of trying out a beta version of this, do reach out to the product team on product@comet.com. And I know that towards the end, we'll also have a couple more links on how you can reach out to the team to learn more about this functionality. But do check out our open source repo, give us a star if it's something that's useful for you, and you are able to use most of the functionality that I've presented today within the Comet platform already. Awesome, so that kind of covers a lot of the improvements that we've made on the large language model side of things. But the Comet platform also supports a lot of other use cases, one of them being computer vision. And of course, a big focus of ours is how to deploy your models to production. And so I'll hand it over to Daniel for him to cover that part of the platform and all of the improvements that we've been making there.
Awesome. Thank you so much, Jack. Let me share my screen. Something's now right here. What screen can you guys see?
We can see Slack.
Now I can't share anything. I lost the ability to be a presenter. All right, about that.
That again.
And now we can properly share the screen. Awesome. Okay. Thanks, Jacques, for covering the LLMs. Kind of shifting focus, right? LLMs obviously being kind of a very rising field. Then the other hand, computer vision and deployment workflows, I think are equally relevant. And so for the long time, Comet has been the leader, right, of allowing you to visualize your media in various forms, right? We have on a single experiment page, we have the graphics tab, On the project page, we've now added the image panel to help you compare your images across experiments and across time, across steps. But for the most part, kind of enhanced capabilities, annotations, edit analyses historically have been more kind of custom analysis. Now, with the recent release of the Comet UI, bounding boxes, segmentation, and generally image metadata are now first-class citizens in Comet, meaning you now have native support for logging your bounding boxes across your different images, across the different classes that you're categorizing, and you can actually easily analyze them from the UI, change the confidence score, and really kind of configure exactly what you want to see, what you want to analyze, both on a single experiment level and on the image panel, as I'll show you in a bit, and really kind of compare how your model is actually predicting and categorizing different items in different classes. Same with segmentations. You now have native support to log, in a sense, segmentation polygons, and masks are coming soon as well, where you'll be able to not just log individual polygons, but actually layer them and use them as masks, right? And finally, image metadata. Images can now contain really any kind of JSON you want. You log it alongside your image, and you can log and retrieve that additional info to be used both in your analysis and kind of productionalization workflows as well. After that, we'll kind of select our champion model and really show you how you can use, how you can transition from kind of the analysis phase to the productionalization phase, right? How you go from experiment management to the model registry, what you can do. We covered previously integration, details on lineage, history, and usage. But really, as your team grow, as kind of your models become more and more complicated, more and more data scientists are collaborating together, it becomes more imperative to have a structured model approval process in place. Now we're kind of shifting from the research to operationalizing of models, and everything you do in the model registry becomes more sensitive, right? One wrong click and something goes to production, you mislabel something, and next time you deploy your pipeline, and something goes wrong, right? So being extra careful in how you manage your data, how you classify your different model versions is imperative, especially since we'll cover webhooks as well for CI/CD integration. And really kind of through this workflow that you see here, you can go seamlessly from the research phase, analyze your models, analyze your computer vision models, and understand how it predicts certain classes across your different architectures or different data sets, choose the correct model that you want to move to the registry, have all the information you're going to need to productionalize it, data, lineage, history, and then in a very structured, auditable way, be able to move that model to production and integrate with your CI/CD system, all very automatic, all as kind of one single pipeline without necessarily needing to leave the platform. Okay. Okay. Kind of to show you what does native support look like in Comet. I'm sure a lot of people on this call know YOLO and Comet have always had a really great collaboration, and what better use case to show than the new YOLO V8. So here I have just a couple of experiments. I downloaded the YOLO V8 library, tuned it a little bit, maybe on my own custom data set, and I really want to see how does YOLO V8 really classify certain objects. Starting with kind of comparison across images, now this image panel that we have today now natively supports bounding boxes. You can see here, can quickly adjust the confidence score if I want to see items that have a lot of confidence, right? This is a bowl with 93% certainty, or I want to see maybe how does my model predict lower confidence items. I can always adjust the individual items I see and the individual items that I'm classifying. If I want to kind of look at the image in a bigger way, I can zoom in. And of course, I can quickly kind of go through images in the image panel. Right? So on an individual image level, I now have this added control of analyzing my annotations. And on the panel as a whole, right, if I just want to set a single consistent standard for analysis across my entire panel, I can either just disable annotations altogether, choose maybe the individual classes that I care about, or just adjust the confidence score through the entire panel. Let's say I care only about what I can categorize with 60% confidence score or above. And so just like that, I click done, and everything is reflected in the image panel, right? Very native, very seamless, and everything is much more embedded into your analysis and into kind of the infrastructure that we've built as a whole. On a single experiment level, again, I also have the image panel here. It works in exactly the same way. I can move around the steps, but now I also have this kind of native support on the graphics tab as well. This looks like a cat. It is a cat. The model says so with 80% confidence, right? So really anywhere you see this kind of enriched media, specifically images, you now have this annotation capabilities that you can play around with, adjust and analyze however kind of makes sense to you. The structure for annotations is extremely simple. It's a list of dictionaries. Here I call my set of annotations, I call it predictions. And this, let me make it a little bigger. And the data, again, is a list of dictionaries. I define my bounding boxes, for example. I define X, Y, width, and height. I can add a label, a score, or even an ID, kind of better management of these classes. And as part of experiment.log image, annotations equal this list of dictionaries. And just like that, I log bounding boxes, similar enough with logging regions or segments, where I specify kind of all the points of my polygon. And here, as you see, I successfully classified a giraffe. Awesome. Now, going back here, our standard workflow, I kind of look at my existing experiment, maybe look which experiment performs better than the other. Now I decide this is the model that I want to choose in order to promote it to production. I can register this model, YOLO V8, that's what I logged previously. It's been registered before, it's part of this model, and I want to continue and registering it as part of this model. The latest version was 2.7. I want to log it as version 2.8.0. I click register model, and just like that, I successfully registered this model, and I can view it in the model registry. So this page is, of course, something you've seen before. I can manage all the different model versions that I have. The new addition is the model approval process, where I now have my status column. And the status column is a special kind of column where, as a, let's say, regular workspace member, I can just easily change, right? I'll show you webhooks in a second, but if I change the status columns, things tied to it, as things change, my CI/CD system can be notified. Let's say I think this is a really great model. I want to move it to, let's say, the staging phase, right? I happen to be a workspace owner, so I can skip the review and just change the status directly. But for our purposes, and kind of most users will experience it, I will submit it for review. Really, you can think of it as a pull request. Under the model page, in pending requests, I now have all the different users kind of submitting these requests, these pull requests in a sense, to change the status of the model from none to staging, from none to development. The workspace owner can approve or reject the request. Let's say for 2.8, I wanted to change it to staging. I can approve, looks good. new campaign model, and just like that, I confirm, and I can see all of these events happening in my history tab. Equally, I've received the appropriate emails. The user who submitted the request has been notified that the status of the request has been approved with all corresponding details, and the requester or the requested, the workspace owner, has been notified that there is now a pending request, an action item for them to take to approve this model. Okay. Why is this so relevant? Why changing the status is so sensitive? Why can it impact production? And that's where our new webhooks UI come in. For this model specifically, I have no webhooks, but I can create a new webhook. I can call it, YOLO V8 prod. Let's say I want to notify Google.com for our purposes, right? Any URL that's kind of listening can be notified. We'll send a post request to the URL that you specify with the appropriate payload with the information about the model. I can specify any kind of secret token that makes sense that will be under the authorization header. And most importantly, I can decide when this webhook, when will Comet send a post request to this URL after these events have happened. In our case, as we kind of discussed, when the model status changes, I want to send a post request to this URL, maybe with some additional metadata in the header, maybe a value that makes sense for my workflow, right? Just like that, I click create, and now I linked my model registry with my CI/CD system. You can link it with any URL, GitHub Actions, what have you. Kind of have a seamless integration and in a very controlled workflows where from experiments, you register a model, you kind of manage your models in a centralized way with the appropriate audit and history, have the appropriate corporate controls, kind of govern the model, and finally connect it through webhooks to your system. Now, the webhook system has been notified. Now it's time to productionalize the model. The last thing I'll show you is what our new model API object looks like. Before, everything was under API, but recently we've released our new model object. So from Comet ML, I'm importing API. I define my API that takes the appropriate credentials, and I can call API.getModel. In our case, from Team Comet ML, that's the workspace, and we just registered this latest model, right? So I have my model object, and from that object, in a very modular way, I can now call all the appropriate kind of methods that I need to find the right model and download it before I actually use it to make predictions. So in our case, let's say I want to find versions where maybe the version prefix is 2, let's say, right? And now immediately I get a list sorted appropriately of all the versions that correspond to kind of version prefix 2. I can do the same with, let's say, 2.8, and I get the appropriate versions. If I had 2.8.1, 2.8.2, it would have been here. And I can even have more control where maybe I don't even need a version prefix, but I want status to be equal to staging, let's say, right? And just like that, I have the right model that I just registered and change the status. And I can call model.download, specify the right version, and just like that, it's been downloaded. I can reload it into the right object and make inference predictions. So see, end-to-end flow is now much more controlled, much more modular, and you now have these deeper analysis capabilities to ensure that what is going to production is the right model and the best performing model. I know we're out of time, but does anyone have any kind of questions that we can answer? If not, to learn more, please visit our documentation, docs v2 guides large language models, and the same with tracking ML training image annotations as well. Finally, if you have any feedback for us, struggling with cloud integrations, or kind of thinking about what orchestration looks like, kind of scheduling runs, rerunning failed training jobs, and things like that, we would love to hear from you. Please book some time. This is my Calendly link, calendly.com/DanielS29. Book 30 minutes. We would love to chat anytime, any day. We want to hear from you. Thank you so much.
Awesome. Thanks very much, everyone, for joining. We're right up on time. It was great kind of presenting some of the features we've been working on over the last few months, and we'll be back with another product update in a couple of months as we continue developing LLMs, computer vision, functionality, and the model registry features that we've been building as well. Thanks very much, everyone.